Hi everybody. I'm gonna try to finish lesson 32. My last video got stuck at like 9 minutes and 30 seconds. You just had to watch me and talk, but without seeing me do any math. So I'm gonna do some math here, and hopefully I can get it done in 5 or 6 minutes. So I'm gonna cover examples 1, 2, 3, and another part of 3. Yeah, so hopefully I can help you know what to do with this exponents and stuff. I'm gonna get up and move out of here. Oh, my legs. Oh, I'm so old. Alrighty. Simplifying expressions with negative exponents. Write it in. I gave you the rule that we follow. I rewrote it over here that if ever you get a negative exponent, that just means it's a reciprocal. You can drop it down to the numerator, to the denominator, and change the sign on that power. So maybe I can put a plus in. Or vice versa. If it's down here and it says a negative, I can bring it up to the top and make it positive. So if I switch it from the numerator to the denominator, the sign switches on the power, on the exponent. So let's talk about this one really quickly. This got a negative exponent, so that's this situation right here. That is equivalent to 1 over x cubed. There's a couple of different ways you could go about writing the answers. One would be to put everything in the numerator. But probably the preferable way that they'll have the answers in the answer would be to write all your answers with positive exponents. So once you've sorted it all out and you figured out what are all the powers on everything, you're going to take anything that's a negative and you're going to switch it from either the numerator to the denominator or the denominator to the numerator so that all the exponents are positive exponents. So I'll demonstrate that. I won't feel good about moving on until I've done that and written my answer with all positive exponents. But we already had the rule about negative exponents, and then zero exponents would be the next thing. And we already know that anything to the 0 power equals 1 doesn't mean we can just turn it into 0. It's still there. It's just anything times 1 is what it is. So sometimes they'll give us a problem, and it'll be one of those evaluate things, like plug the numbers in where the letters are and then do the math. And the first one that they give you of those is a squared b to the 0. Now you might be tempted to just save those on your calculator and then type in b to the 0, but that's silly. That's too much work. In this problem, b to the 0 equals 1, so you don't even need to plug in that -3 in there and take it to the 0 power, because anything to the 0 power is 1. So anytime you see a something to the 0, you can just put a 1 there. Not b to the 1, just 1. And now all you have to do is plug in right here where there was an a, you can plug in a -2. And this means -2 times -2 times 1. So -2 times -2 is 4. Okay, so this problem right here equals -2 times -2 times 1 is 4. Yay, give yourself a hand clap. Good job. Okay, now the next one has got two things that are b's, and they are two different powers. And you could just type in the b and do it that way, but it would be better to take those b's together and put them together first, and then clean up the negative exponent business. So this b here is actually a b to the 1 power. It's just 1b, right? It's not b squared, it's just b. The rule for if you've got the same bases, both of those bases are b, is that you're allowed to go -3 and the +1. You're allowed to combine them like that. It's one way that you can attack this problem. And b to the -3 plus 1 is b to the -2. -3 plus 1 is -2. Now that's a good answer, but that's not without negative exponents. We want positive exponents. And we already know that something to a negative exponent can be brought down to the denominator, and we can change the signs. So this one becomes 3 There's nothing to do with that, but that b gets dropped down here, and we can change that sign to a positive 2. And that is the preferable way to answer that question. Now, another thing I could have done would be to take that b to the negative 3 and dropped it down right away. I could have had 3, I could have left this b up here and then bring this b down there. Could have done that, and then I could see that b divided by b, I could cancel a b out of both the top and the bottom. If I take one b out of here, b times b times b is b cubed, but b times b, if I take out a b, then I would have b squared. And that's the same as this is. This depends on kind of what your preference will end up being with those types of problems. But here I see that they're the same base, so I've got a rule to fix the exponent, and then I've got a rule to fix negative exponents, so I can write an answer with all positive exponents. That's example 2. Let's take the third one. There now. Using the quotient rule. And the quotient rule says if you've got the same base, x or a or b or whatever, and you got one thing with a power in the numerator and another thing with a power in the denominator, you can bring that bottom one up and change its sign, and then use the product rule by just adding or subtracting their powers. So it's like two steps in one step. You notice that the same base, when you bring that x to the n up, it's going to become x to the negative n anyway. And then, rather than going x to the m times x to the negative n, we've got x to the m minus n in one fell swoop. So you could do it that way. Now, here we could notice that really x to the 7th would be having 1, 2, 3, 4, 5, 6, 7 x's over 3 x's, and you can like cancel out. That's 1, that's 1, that's 1, and here's what you're left with, which is x to the 4th. If you like to draw pictures and color over things, that's fine, but the rule says we can go x to the 7 minus 3. When this comes up, it becomes negative 3. When we add those exponents together, we will get x to the 7 minus 3 is x to the 4. Same answer, but I can do it in much fewer steps if I use the rule. We can have the same thing here. If I follow the quotient rule, this turns into x to the 3rd, and then when I bring this up, its sign changes. And it would become, basically we would be doing minus negative 7, right? X to the 3 plus 7. The sign comes up, we can do that with it. But following the quotient rule, we could write it like this and get x to the 10th. Positive exponents now, I've kind of done it the way I should. I've got an answer that's cleaned up a little bit. And then we'll throw in a really big yucky one. This is going to be as complex as they get for these. Negative 3y squared and an x. Okay, I got some methods we can go and take care of this. One thing is that it might be useful, since there's z's and x's and y's all over the place. Let's put them all in the numerator, and then put them together, and then see if there's anything that's negative that I need to bring back down. So let me demonstrate that, give myself a little bit more room here. And this will be my last example. So that x up there is going to stay up there for now, even though it's got a negative on it. This x is x to the 1, and I'm going to bring it up, and when I bring it up, it becomes x to the negative 1. This y is up there, it's just going to stay up there. This y is a positive 2, but when I bring it up, it becomes negative 2. And then I've got a z up there, that's a z to the 1. And when this z comes up, its sign changes and becomes z to the 3. Everything now is over 1, still a fraction, but everything's in the numerator. Now let's squish it all together. And I got x to the negative 5 minus 1. I'll have y to the 6 minus 2, and I have z to the 1 plus 3. So this first one becomes x to the negative 6. Second one becomes x to the 4th. And z becomes z to the 4th. Now, I've just got one exponent on each of those variables, but this is not preferable to have that negative there. So I got one more step, and that would be to drop this back down to the denominator and change its sign. Okay, so that comes down here, it becomes x to the positive 6. And now everything has one exponent, and everything is positive. That's one way to tackle that problem. I could think of other ways to do it, like cleaning it up at the beginning and then finishing off. I mean, kind of if you look at the beginning, you can figure out where it's going to be positive or negative if I move the thing. This is, start with the x's. If this x moves down here, its sign switches and becomes x to the 5th. And I would have x, that x, and then I bring this x down, and it's to a positive 5, and that's positive 1. So the x to the 6th ends up down here. The y's, there's more positives up here than down here. When this one comes up, it does just what we thought it would do, and we could use that rule 6 minus 2. The z's, we have big negatives. We're going to move that up. It becomes even more positive. We have 1 plus 3. So that could have gone down first if you realize that that's not in the right place. If I move it down, it becomes positive and combines with another one that's positive. Either way, you're going to get y to the 4th, z to the 4th over x to the 6th. Like I said, that's as complicated as those ones get, but just take one letter at a time. Don't try to do it in order or whatever. Just take one letter at a time and either move everything up to the top first, squish them together, and then see if anything needs to move back down. Or just decide right away, if I've got an x up here and an x down there, which one should move so that I end up having a positive exponent when I'm all done. Okay, that's kind of a thinking cap kind of thing, but I think you can do it. Hopefully that helps, and hopefully the whole thing got recorded.